So last time we were talking about oblique asymptotes. This is where we ended the last video. We said that an oblique asymptote is an asymptote that's a slanted line. So in other words, it's not a vertical asymptote or horizontal asymptote, so the slope's not zero or undefined. It's got a positive or a negative slope. And how we're going to tell if we have an oblique asymptote is if the degree of the numerator is exactly one more than the degree of the denominator, then you have an oblique asymptote. We're going to find these oblique asymptotes by using long division. So let's look at an example. So we want to find the asymptotes and graph the functions using a graphing calculator. The first function is f of x is 8x squared minus 26x plus 21 divided by 4x plus 1. I'm going to find some similar information as I did in the last video. I want to find the domain. I want to find any vertical asymptotes, any horizontal asymptotes, and any oblique asymptotes. So let's start with the domain. Now remember, to find the domain, we just look at the bottom part of the fraction. Put this in a different color here. And we ask ourselves what value for x, when we plug it in, makes this denominator 0. So if 4x plus 1 is 0, that tells us that 4x is negative 1, or x is negative 1/4. So when x is negative 1/4, we get 0 in the denominator. So the domain is all values except negative 1/4. And to write this in interval notation, this is what you'll get. So just make sure you take out that negative 1/4. Now to find vertical asymptotes, remember that vertical asymptotes correspond to problems in the domain when you've simplified the function. So let's see if we can simplify this at all. What I'm going to do is I'm going to factor the numerator. Now, notice that this is a quadratic, and this is actually factorable. I'm not going to go through all of this. You can factor this on your own, but what you should get is 4x minus 7 times 2x minus 3. So if you FOIL this out, you'll see you get 8x, then a minus 12 and a minus 14, which make a minus 26. And then 7 times 3 is at 21. Okay, so this is the factored form. And notice that we don't have 4x plus 1 occurring in the numerator, so we can't cancel anything out. So this is as the simplified version, the most simple, like the simplest form we can get this function. We can't cancel anything out. So we're still going to have a problem at negative 1/4. So that's going to correspond to our vertical asymptote. So a vertical asymptote, we're going to have one at x is equal to negative 1/4. Again, this is a value x that we can't plug into the domain, and this is the line x is equal to negative 1/4. Now, for a horizontal asymptote, we're going to have a horizontal asymptote for two cases. One case is when the degree of the numerator is less than the degree of the denominator, and the second case is when the degree of the numerator is equal to the degree of the denominator. Notice that here, if I erase this, the degree here of the numerator is 2. So I'll write that over here. The degree of the numerator is 2, and the degree of the denominator is 1. Since the degree of the numerator is not less than or equal to the degree of the denominator, we do not have a horizontal asymptote. Because the degree of the numerator is 1 more than the degree of the denominator, we do have an oblique asymptote. The oblique asymptote is going to take the form y is equal to ax plus b. We need to find the a and we need to find the b. And to do that, we're going to use long division. So what I'm going to do is I'm actually going to take this 8x squared minus 26x plus 21, and I'm going to divide it by 4x plus 1. And I'm going to get something that's going to be a number times x plus just a constant, and then I might get a remainder. But if we get a remainder, we just don't even worry about the remainder. We just cross it out. Let me show you what I mean. So I'm going to write this fraction down here. So I'm going to do long division, 8x squared minus 26x plus 21. That's the numerator. I'm going to divide that by 4x plus 1. Okay? So I ask myself, what do I need to multiply 4x by to get 8x squared? Well, that would be 2x. So I'd have 8x squared, then 2x plus, multiply that by 1, we get plus 2x. Now we subtract everything, which means we get rid of all of these signs. We make this a negative and this a negative. And this becomes a negative 28. X, bring down this 21. And then we ask ourselves, what do we need to multiply 4x by to get negative 28? Well, that would be negative 7. Negative 7 times 4 is negative 28. We also have the x. And then we get a negative 7 because of this negative 7 times this 1. Again, subtract this. That means we switch all the signs. And notice that we're going to get a remainder here. This will be 28. That's our remainder. And I'm just going to ignore that because what I'm looking for is this piece here. Now, 4x plus 1 doesn't go completely into this polynomial, again, because it's not a factor. You can see it's not a factor up here. So we get a remainder. But for the oblique asymptote, we don't care about the remainder. So this a is 2 and this b is negative 7. So the oblique asymptote is the line y is equal to 2x minus 7. So you can't have a horizontal asymptote and an oblique asymptote. You can have neither, or you can have a horizontal asymptote, or you can have an oblique asymptote. Okay, so now that we have all of this information, we're going to graph this function on a graphing calculator. Before I do that, I just want to have some kind of idea of what this is going to look like. Just got some stuff over here, so let me just get rid of that real quick. Okay, so what I'm going to do is I'm just going to kind of sketch a plane, and then I'm going to put the vertical asymptotes and the oblique asymptote just to get an idea of what's going to happen. Okay, so let's erase this. I'm going to sketch this right here. So let's put this in black. Okay, so we have a vertical asymptote at negative 1/4. So if this is negative 1, a fourth of this, about right here. So we're going to have some kind of asymptote here. Then we're also going to have a oblique asymptote at 2x minus 7. Now this is a line that has a y-intercept of negative 7, so way down here, negative 7. And then a slope of 2, so up 2 over 1. So what's going to happen is you're going to get something that looks something like this. In fact, let me move this down and continue this. So what's going to happen in our graph, when we graph this, the end behavior is going to follow this oblique asymptote. So we might have a graph that looks something like this. So we follow this oblique asymptote, or maybe something like this, where this part goes up towards this asymptote. We could also have, instead of that, we could have something like this. But the idea is the end behavior goes with the oblique asymptote, just like the end behavior went with the horizontal asymptote. And then with where these vertical asymptotes are, we're either approaching positive infinity or negative infinity. So let's see, I'm going to switch over to my graphing calculator. And we're going to graph this. So let me share my graphing calculator. Okay. So the function that we're trying to graph is y is equal to 8x squared minus 26x plus 21. That's being divided by 4x plus 1. So let me zoom out a little bit. And now you can see what is happening. Just like we expected, we have a vertical asymptote. And you can see as we get closer to negative 1/4, so I'm going to just pull, let me close this and zoom in a little bit. So if I just touch this graph, you see my x value is 0.181. So I'm just going to move kind of like to the left. And as I move to the left, you can see these values are getting smaller and smaller. Let's zoom out a little bit. You see they're going into the negative. And so they're getting closer and closer to that negative 1/4, which is negative 0.25. But you can see the y values, they're getting bigger and bigger. So here I'm at 30, 31, so approaching infinity. Down here, we have a similar situation. So if I'm coming towards negative 0.25 from the left, we're going towards negative infinity for the y values. Now, when we're looking at the end behavior of this graph, you can see that this end behavior kind of looks like a straight line. And in fact, if I graph the line that we found, which was y is equal to, I believe it was 2x, let me just double check. It was 2x minus 7, so 2x minus 7. You can see like these two graphs look like they almost line up right on that, that asymptote here. See that? So if I zoom in, you can see that this red line is really close to that blue line. You can see right there. Zoom in even further. The more you zoom in, you can see that they're not exactly on each other, but they're pretty close. So if we keep scrolling up, 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 they look like they're getting closer. But if I zoom in, you can see they're still not touching. And they never will touch. The further you go out, they're going to get closer and closer, but they're not actually going to touch. And yes, you can cross an oblique asymptote in the middle here, but the end behavior always goes towards that asymptote. Okay, let's switch back. So we're going to go back to our OneNote here. Let's try another problem. So let's zoom in a little bit. So here I have g of x is 4x cubed minus 16 divided by x squared minus 2x plus 1. Let's find the domain, the vertical asymptotes, the horizontal asymptotes, and the oblique asymptotes. So let's start with the domain, then vertical asymptotes, horizontal asymptotes, and oblique asymptotes. Okay, to find the domain, we need to factor the bottom. This is something that's easy to factor, and I'm actually going to try to factor the top as well. Notice that I can take out a greatest common factor of 4. So I get x cubed minus 4 divided by, this is actually a, what do you call it, perfect square here. This is x plus 1 times x plus 1. Notice you get x squared, minus 1 minus 1. Because you get x squared, and then a minus x and minus x, which make a negative 2x, and then a plus 1. The top, we could try to factor a little bit further. Notice that if x cubed minus 4 is 0, then x cubed is 4. But our roots are just going to be the cubic root of 4. So x minus 1 definitely doesn't go into here. Plus, if you plug in 1 here, you get 1 cubed minus 4, which is negative 3. Remember the remainder theorem. If x minus 1 divides this, so if it's a factor of this, then if you plug in 1, the opposite of what you see here, you should get 0 when you plug it into the polynomial. Because we don't get 0, this x minus 1 doesn't factor it. And the reason that's important, the reason I'm bringing that up, is because if it did factor it, then we would be able to cross this, we would be able to cross out an x minus 1 here and an x minus 1 here, and we would have a whole if we didn't have like x minus 1 in the bottom. If we were able to get rid of something and simplify it. But this can't be simplified any further because x minus 1 is not a factor of this. Okay, so for the domain, we have a problem when x is 1. You can see if I plug in 1, we're going to get 0 in the denominator. So the domain is negative infinity to 1, and then 1 to infinity. Because I cannot simplify this further, we do have a vertical asymptote, and it is at x is equal to 1. Now, let's go back to this version, because I think this version is a little confusing when we have to determine horizontal asymptotes and oblique asymptotes. Now we look at the degree of the numerator. So the degree of the numerator is equal to 3. That's the highest power here. And the degree of the denominator is equal to 2. Because the degree of the numerator is not less than or equal to the degree of the denominator, there's no horizontal asymptote. Because the degree of the numerator is 1 more than the degree of the denominator, we do have an oblique asymptote. And it's y is equal to ax plus b. Now to find the a and the b, we have to divide this 4x cubed minus 16 by x squared minus 2x plus 1. So let's do that. I'm going to move this down here. I'm also going to expand this. Instead of writing 4x cubed minus 16, I'm actually going to put plus 0x squared plus 0x minus 16, because that's going to save us a lot of trouble and a lot of grief when we do this division. Now I'm going to put the denominator here. Okay, and this is very similar to what I did before. I asked myself, with this first term here, what do I need to multiply it by to get this first term here? So I have to multiply by 4x. If I do that, I get 4x cubed. Then I send it here. That's a minus 8x. And then send it here, plus 4x. Now we subtract the whole thing, which means we change all the signs. This one should go away, which gets 0x cubed. And then I get an 8, sorry, this should be x squared. Forgot to make that a square here. So 8x squared minus 4x, and then we pull down the negative 16. Okay, the next part is, what do I need to multiply x squared by to get this 8x? We need to multiply by 8. Now, you're always going to get, for the first term here, just an x times a coefficient. If you get any other power here other than an x, then it is not an oblique asymptote. You're having a problem because then the degree of the numerator is not 1 more than the degree of the denominator. So you should always get something times x plus a number. Okay, so like I was saying, we need to multiply this by 8. So we get 8x squared, then a minus 16x, 8 times negative 2, and then a plus 8. Now we subtract everything. And this part really doesn't matter, because what we're going to get is 16, we get 12x, and this looks like a minus 24. This is our remainder. When we get past this point, when we get past the constant and we get something like this, we don't want that. Don't worry about that. This is the oblique asymptote. So it's going to be 4x plus 8. Okay, I'm not going to sketch this one. I think we have an idea of what this looks like. We're going to have a vertical line at 1 and an oblique asymptote at 4x plus 8. So let's see. I'm going to switch to my graphing calculator. Okay, and I'm going to get rid of the stuff I already wrote. I'm going to put y is equal to 4x cubed minus 16 divided by x squared minus 2x plus 1. Okay, so let's look at our picture here. And what do you see? You can see that we definitely have an asymptote right here. And we said that this asymptote was at 1. And let's see if we can verify that a little bit. If I click on this graph, you can see as I get closer to 1, the x values, it looks like we're going to negative infinity. And on this side, we're also going to negative infinity. Then right here, it looks like we are following some kind of line, which we said the line was, let me look back at this, 4x plus 8. So y is equal to 4x plus 8. And you can see that these two graphs look like they line up pretty well. Let's zoom in a little bit. Now, if the graphs didn't look like they line up, you can see right here it's getting closer and closer. If for some reason this graph, if you plotted, it was way over here like this straight line, and it didn't look like they were lining up at all, then you have made a mistake when you were doing your long division. So that's something to keep in mind. And that is the graph of this one. Very interesting. Now let's go back, and we're going to look at one more example down here. Okay, we're going to do the same thing. We're going to ask for the domain, the vertical asymptotes, the horizontal asymptotes, and the oblique asymptotes. Okay, let's start with the domain. What can we not plug in to the denominator? Well, x squared minus 7 can't be 0, which means x squared can't be 7, which means x cannot be plus or minus square root 7. So because x cannot be plus or minus square root 7, the domain is negative infinity to negative square root 7, then negative square root 7 to square root 7, don't forget this piece, and then 7 to square root 7 to infinity. What about the vertical asymptotes? Again, we need to make sure we don't have any holes, and to do that, you need to factor the top. You should review how to factor this. I'm going to skip this step. Notice that this is a degree 4 polynomial. In fact, we're going to revisit this in either the next, probably the next video or the one after that. So I will show you how to, excuse me, how to go back through this and factor it. But we've done this before. Remember, you have to find potential zeros by taking this 4 and dividing by 9 and all of that. But this factors into 3x minus 2, 3x plus 2, x minus 1, and x plus 1. And on the bottom, we factor into x minus square root 7, x plus square root 7. Now, if for some reason in the numerator I had x minus square root 7 or x plus square root 7, I would cross those out. And that would correspond to a hole, not a vertical asymptote. But because we cannot get rid of anything, whatever's left in the bottom, those are vertical asymptotes. So x is square root 7 and x is negative square root 7 correspond to vertical asymptotes. Now we're going to look right here. We don't really need this piece anymore, so I'm going to erase it. I just don't want it to look so cluttered. Horizontal asymptote. We look at the degree of the numerator. The degree of the numerator is 4. The degree of the denominator is 2. Here's the 4, here's the 2. Okay, we have a horizontal asymptote if the degree of the numerator is less than or equal to the degree of the denominator. Because that's not the case here, we don't have any horizontal asymptotes. We have an oblique asymptote if the degree of the numerator is 1 more than the degree of the denominator. That would mean this would have to be a 3. Because that's not happening here, we do not have an oblique asymptote. But I do want to mention that this graph, when we graph it, it will resemble a particular function at the ends. And what it's going to resemble, so it's going to resemble at the ends the power function. What you need to do is you just have to take, this was a square, you take these two right here and you divide them. So y is equal to 9x to the 4th over x squared. And if you simplify that, that's 9x squared. So at the ends, it's going to kind of look like a parabola. So you're going to be going up. Your end behaviors, the way it's going to look like is going to look sort of like a parabola. I'm going to show you this in a graph. So let's summarize what we're going to see when we graph this. We're going to see two vertical asymptotes. We are not going to see a horizontal or an oblique asymptote, but we're going to have something interesting happening at the end behavior. So let's share our screen here. Let's get rid of the last graph. And now we're going to put in y is equal to 9x to the 4th minus 13x squared plus 4 divided by x squared minus 7. And yep, okay. So let's look at this graph. Let's zoom in a little bit and see what we notice. Okay. So what we notice, what is the square root of 7 first off? So I'm going to put square root 7. This is about 2.65. So 2.65, if you look here, 2.65 is about right here, right? Here's 2.5, so it's a little bit bigger. And we had that this was a vertical asymptote. In fact, let me put x is equal to that. And then we also had x is equal to negative square root 7. That was also a vertical asymptote. Now I'm going to zoom out. And let's see what's happening here. Look how those ends of this function, when we zoom really far out, they're kind of approaching. I can zoom out even further. You can see that they're not going to cross those two asymptotes. You can hardly even see the black line compared to this blue and this red line because they are asymptotes. And if we zoom in, let's look at the end behavior here. Now you can see how they're approaching this asymptote. They are getting close to the asymptote, but the way that they're getting closer, if we just flip this piece over, doesn't it kind of look like a parabola, these sides? They're going up sort of like in a parabola way. And that's because of the end behavior. It so happened that for this particular graph, we don't have anything on this side or this side, which is interesting. We could have, but the end behaviors of the graph, they're definitely parabolic. So you can see it's not like a straight line how it's going this way. It has a lot of curve right here. Okay, so let's switch back. So the next thing we're going to do, the next video, is we're going to start graphing these rational functions. We've learned several things about rational functions that are going to help us to actually graph them. But we're also going to plot some points. We're going to find intercepts and some extra points that can kind of guide us to what this graph is going to look like. So I'll see you in the next video.